Today we are moving on to equations. So we have spent all week on just expressions. Does anybody remember the difference between an expression and an equation? We talked about it briefly earlier this week. An equation has something that an expression does not. Anybody know what that is? What do you think an equation has that an expression does not? What makes them different?
An equation has an answer.
And an equal sign. An equation has an answer and an equal sign. Now, sometimes an equation may be written with like two different expressions on either side of the equation sign. So it might be like 2 plus 5a equals 3 plus something else. And you have to solve both sides of it to see if they equal the same thing, okay? So the main thing that an equation has that an expression does not is an equal sign. So we're going to write several examples of expressions, but then we're going to write that same example as an equation, okay? So our first part is going to be expressions. Numerically, an expression may look like this, using numbers, but there is no equal sign with an answer. Okay, the equation version of this would be 9 plus 3 equals 12. That is an equation. In words, I might see a number plus 3. But an equation in words would say, I'm going to have to make my pen size a little bit smaller because it's real bubbly. A number plus 3 is 12. So when you see something like this and it says a number plus 3 is 12, we don't usually say a number plus 3 equals 12. We say it in sentence form. A number plus 3 is 12. So is means equals. That's an example of an equation in word form. Algebraically, we just got done working with a ton of expressions with variables. Might look something like this, n plus 3. But an equation may look like this, n plus 3 equals 12. And those are what you're probably most familiar with in Saxon from years past. We would have a ton of problems that look like this, where it would say solve for n. And then you just basically work backwards. Or it was a box if it wasn't a variable. Okay, so we have an example. Actually, we have several. Bill scored 13 points in a basketball game. His teammates all together scored X amount of points. The total points of Bill's team was 44 points. Write an equation for this situation. So I am looking at Bill's points. I'm combining Bill's points, what he scored, plus his teammates' points, to equal what? The total points. So the information I'm given, it tells me Bill scored 13 points. His teammates scored X points, and the total points was 44. Okay, that's all the information that I have so far. Now, if I want to actually write down what this would look like in equation form, not just word form, then I would show what Bill's points is represented by. How many points did he score? 13. Plus, what are the teammates' points represented by? X equals, what's the total? 44. So my equation looks like this. 13 plus X equals 44. In order to solve that, it doesn't ask us to solve it. In order to solve that, you would basically do the inverse operation. We're going to talk more about that next week. Solving equations. Right now we're focusing on writing equations from a word problem. Okay? All right. Next, Craig has a fish tank that contains 11 fish. There are 4 guppies and Y other fish. We don't know how many other fish, but there's Y. We're using Y to represent. So, I have guppies plus other fish equals total fish. How many guppies do I have? I have 4 plus how many other fish? We're not solving. What do I use? Y equals 11 total fish. You see, we're just pulling out the information to create an equation to represent that problem. We are not solving them. We are only writing the equation. This is what your practice is today too, okay? There are 5 red candies and X yellow candies in the bowl. There are twice as many yellow candies as red ones. So what is the total? Okay, there's a key word in here that's super important that we talked about. Yep. What does that mean? Double, which means times 2 multiplied by 2. Okay, so I'm looking at red plus yellow is my total. So to represent this as an equation, how many red do I have? 5. Plus, what does it tell me about yellow? There's twice as many. So I would do 2x. If I didn't know how many there was, I would just do 2x equals, wait, no, that's not right. I'm gonna say equals question mark. We might normally put a y there if we're doing like 2 variable type equations. But what would I do to actually solve this if I wanted to solve this? I would plug in, I would replace this x with 5 so that my equation would look like this. 5 plus 2 times 5. And then I see that 5 plus 10 would equal 15. Okay.